Imagine a world so wild, so extreme, that it defies everything we think we know about planets. A place where temperatures swing from freezing cold to molten hot in mere hours, where gravity tugs at its core with relentless force, and where its very existence challenges our understanding of the cosmos. This is HD-80606b, a planet shrouded in enigma, orbiting a star 190 light-years away. Discovered over 2 decades ago, it's not just another to the sky. It's a cosmic puzzle begging to be solved. Why does this planet behave so strangely? What secrets does it hold about the universe? And perhaps about our own place in it? In this journey, we'll peel back the layers of HD-80606b, diving into its fiery heart and icy edges to uncover what makes it one of the most bizarre worlds ever found. Buckle up. This isn't your average exoplanet tale. It's a story of chaos, discovery, and the relentless quest to understand what lies beyond. HD-80606b isn't just a planet. It's a question mark written across the stars. Today, we'll explore its past, decode its present, and dare to predict its future. Are you ready to step into the unknown? Let's rewind to 2001, when the universe handed us a surprise. A team of astronomers, led by Swiss scientist Unveiling, was peering through telescopes at the star HD-80606, a sun-like giant in the constellation Ursa Major. Using the radial velocity method, tracking a star's subtle wobble caused by an orbiting planet, they stumbled upon something extraordinary. HD-80606b wasn't like the orderly worlds of our solar system. Its orbit was a stretched-out ellipse, not a neat circle, swinging it perilously close to its star and then flinging it far away. This wasn't just a discovery, it was a wake-up call. Planets, it turns out, don't always play by the rules we expect. The discovery came during a golden age of exoplanet hunting. The 1990s had already shocked the world with 51 Pegasi b, the first confirmed exoplanet around a sun-like star, found by Michel Mayor and Didier Queloz, work that later earned them a Nobel Prize in 2019. But HD-80606b took things further. Its extreme orbit, dubbed eccentric in astronomer speak, hinted at a violent past. Was it a wanderer, kicked into chaos by a cosmic collision, or a survivor of a star system gone haywire? The questions piled up faster than the answers. By 2009, NASA's Spitzer Space Telescope caught HD-80606b in action, observing a dramatic temperature spike as it whipped past its star. In just 6 hours, its surface soared from 800 degrees Fahrenheit to 2,200 degrees Fahrenheit, 426 degrees Celsius to 1,204 degrees Celsius, hot enough to melt lead. This wasn't just data, it was a glimpse into a planet's wildlife. Scientists like Gregory Laughlin, who analyzed the Spitzer observations, called it a front-row seat to planetary chaos. The backstory of HD-80606 was shaping up to be a tale of extremes, forged in the fires of discovery and fueled by humanity's growing obsession with the stars. Back then, each new exoplanet rewrote the rulebook. HD-80606b wasn't just a find. It was a challenge to rethink how planets form, move, and survive. And it all started with a wobble in a distant star's light. So, what is HD-80606b? Let's break it down step by step, starting with its orbit, the strangest feature of all. Picture this. Most planets, like Earth, trace near circular paths around their stars, keeping a steady distance. HD-80606b, it's on a roller coaster. Its orbit stretches into an ellipse with an eccentricity of 0.93, nearly a straight line by planetary standards. At its farthest, it's 88 cent from the star, about Earth's distance from the Sun. At its closest, it plunges to just 3 cents, skimming a mere 2.8 million miles, 4.5 million kilometers, from HD 80,606's surface. That's 25 times closer than Earth ever gets to the Sun. In 6 hours, it swings through this periastrum, its closest approach, enduring a blast of stellar radiation that turns it into a cosmic furnace. Imagine the chaos that unleashes. As it nears its star, HD-80606b's atmosphere ignites. Winds scream at supersonic speeds, up to 11,000 miles per hour, 17,700 kilometers per hour, whipping heat around the planet like a blowtorch. Scientists estimate its mass at 4 times Jupiter's, making it a hot Jupiter, but its wild orbit sets it apart. It's like a planet on steroids, says Heather Knudsen, an exoplanet expert who studied its atmosphere. Infrared data from Spitzer revealed a shockwave racing ahead of the planet, heating its gases to a glowing inferno. This isn't just hot, it's apocalyptic. But why such a bizarre orbit? One theory points to a turbulent birth. Billions of years ago, HD-80606b might have formed farther out, only to be shoved inward by gravitational tug from a companion star, HD-80607, just 1,200 Australian dollars away. This binary system could have played tug of war with the planet, stretching its orbit into the extreme ellipse we see today. Another idea? A near miss with another massive object, a rogue planet or star, sent it careening off course. Its orbit screams chaos, says Jonathan Fortney, a planetary scientist. Something big happened to this world. Let's zoom into its surface, or what we imagine it to be. HD-80606b is likely a gas giant with no solid ground, just layers of hydrogen and helium swirling under crushing pressure. At its hottest, silicate clouds, think vaporized rock, might condense in its atmosphere, only to evaporate as it swings away. During its cold phase, it dips below freezing, a stark contrast to its fiery peak. Astronomers have detected water vapor, methane, and carbon dioxide in its air, hinting at a complex chemistry shaped by its wild ride. It's a natural lab for extreme physics, notes Drake Deming, who observed it with Spitzer. Then there's the star itself, HD-80606, a G-type star slightly bigger and hotter than our Sun. Its gravitational grip locks the planet into this dance of extremes. But could it also be its doom? Some suggest tidal forces, stretching and squeezing the planet, generate internal heat, adding to its force. Over time, these forces might circularize its orbit, but that's a process spanning millions of years. For now, HD-80606b is a survivor, teetering on the edge of stability. How does it hold together under such stress? That's the million-dollar question. By 2019, the Hubble Space Telescope joined the hunt, capturing ultraviolet light from the planet's atmosphere as it grazed its star. The data showed hydrogen escaping into space, a sign it's losing mass, bit by bit. Could this be a glimpse of a planet unraveling, or a testament to its resilience? HD-80606b isn't just a world. It's a cosmic experiment, pushing the boundaries of what we believe planets can endure. Fast forward to 2025, HD-80606b remains a hot topic, literally and figuratively. Today, astronomers are armed with better tools, like the James Webb Space Telescope, JWST, launched in 2021. Early observations of HD-80606b with JWST's infrared eyes have sharpened our view, revealing more about its atmosphere's composition and dynamics. We're seeing deeper than ever, says Nicole Cologne, a JWST scientist. Water vapor and methane levels fluctuate wildly with each orbit, a testament to its brutal temperature swings. This isn't just trivia, it's a window into how extreme world evolved. But challenges persist. Observing HD-80606b is tricky. Its transits, when it passes in front of its star, are rare and brief, lasting just hours every 111 days. Coordinating telescope time is a logistical nightmare, and the data's complexity taxes even the sharpest minds. Plus, its distance, 190 light years, means we're studying light that left it nearly 2 centuries ago. What we see is a snapshot of its past, not its present. Are we missing the bigger picture? Still, progress is undeniable. Recent models suggest its atmosphere might be layered, with hotter gases rising and cooler ones sinking, driven by those supersonic winds. Scientists are also probing its mass loss. Estimates say it sheds 10 to the power of 9 kilograms per second, a slow bleed that could reshape it over eons. It's a living case study, says Eliza Kempton, an exoplanet researcher. The current trend? More missions, like the European Space Agency's Ariel, set for 2029, aim to target eccentric worlds like this one, promising richer data. HD-80606b is no longer just a curiosity. It's a key to unlocking exoplanet secrets. What lies ahead for HD-80606b? Gaze into the cosmic crystal ball, and the possibilities are as wild as the planet itself. One scenario, its orbit could stabilize. Over millions of years, tidal forces might round out that ellipse, turning it into a more typical hot Jupiter, locked in a tight, circular path. It's a slow grind, predicts Jonathan Furley, but it could settle down eventually. Temperatures would even out, ending its roller coaster days. Would it still be the same planet then? Or maybe it's doomed. That hydrogen escape Hubble spotted? It might accelerate, stripping its atmosphere until it's a bare core, a Chthonian planet in astronomer lingo. Picture a rocky husk, scorched and silent, orbiting its star as a ghostly relic. It's plausible, warns Heather Nixon. Extreme orbits breed extreme fates. In this future, HD-80606b could vanish into the cosmic graveyard, a cautionary tale of planetary fragility. There's a third path, survival of surprises. New tech, like aerial or even star-shade missions blocking starlight, could reveal hidden moons or rings, wildcards that change everything. Maybe it's tougher than we think, clinging to its atmosphere against all odds. We're just scratching the surface, says Nicole Colon. Whatever happens, HD-80606b will keep teaching us about resilience, chaos, and the untamed corners of the universe. HD-80606b isn't just a planet, it's a story. From its chaotic discovery in 2001 to its fiery dances captured by Spitzer and Hubble, it's shown us a universe far stranger than we ever imagined. A world of extremes, it teeters between destruction and endurance, whispering secrets about how planets live and die. We've learned it's a hot Jupiter with a wild heart, shaped by a violent past and facing an uncertain future. But here's the kicker. Every fact we uncover about it reflects back on us. Our curiosity, our tools, our drive to know more. So what hides HD-80606b? Maybe it's the answer to how chaos breeds beauty, or a warning of what happens when worlds push their limits. As we watch it swing through the stars, one thing's clear. The universe is full of mysteries, and this planet is daring us to solve them. What do you think its next chapter holds?